So hello students, so this is second subtopic of the first unit of IB Diploma Chemistry, and this is the mole concept. So what are the objectives in this subtopic? So to apply the learning of relative atomic masses, to calculate the molar mass of chemical species like atoms, molecules and ions, to calculate the amount of reactants and products in moles and the mass in grams, to determine the empirical formula and the molecular formula from the percentage abundance of constituent elements, to be able to calculate moles, molar mass and mass of a substance. Now what you need to take care during this subtopic, the mole is a quantity while mole, mole is its unit. So normally I seen that students are very much confused between this mole and mole, where and which word we need to use. So that is why it is to be for taking care. Often students remain confused, so there should not be any confusion from now onwards. You can look for the Avogadro's constant in section 2 of the data booklet for paper 2 and paper 3. However, paper 1 questions it will be given if it is needed for the question or something to use with. The TOK related content for this subtopic, that is, we know that population, if we convert it into moles and we write it into scientific notation using Avogadro constant, it will be huge. So that is like you can link it with TOK. The real life connections for this subtopic, like in research and industry, we widely use the stoichiometric calculations. So these calculations are used in food, medical, pharmaceutical, manufacturing, and then space industry. So in various part of our life or in industry, you can use this subtopic in terms of moles or masses or like percentage abundance or something like that. So the major keywords during this unit or during this subtopic of this unit, like molecular formula, mole, Avogadro's number, molar mass, relative atomic mass, relative molecular mass, empirical formula. So you must be aware of all these terms or keywords. So it will help you to understand and to apply this in larger perspective after this unit as well, or after this subtopic as well. So what is a mole? So basically, one mole is an amount of a substance which contains as many particles as there are in 12 grams of carbon 12 isotope, and that is 6.022 into 10 to power 23. That is one mole. 6.022 into 10 to the power 23 is known as Avogadro's number or Avogadro's constant. It is an important part of mole concept, though you need not to recall it because it will be provided to you in data booklet, which I have already told you where you will be given. So this will be given in section 2 of the chemistry data booklet. So you need not to recall it, and you will be using it for paper 2 and paper 3 questions. So it is basically denoted by Na or sometime L, and this number is 6.023 or 22 into 10 to the power 23. Now moving further, mole. What is a mole in terms of formula or equation? It is the mass of a substance over molar mass. So that is we can interchange. So if we want to calculate mole, so what is mole? Mole is mass of any substance divided by its molar mass. And what is molar mass? So molar mass is the mass of 1 mole of a substance in grams. So for example, like if we say molar mass of water, so how do we do that? So H2O, the formula of water, and 2 hydrogens and 1 oxygen. So mass of 2 hydrogen is 2 gram plus oxygen's mass is 16. So together 16 plus 2 is 18 grams. So 18 gram is the molar mass of H2O. So for calculating molar mass, you need to add the relative atomic masses of all the atoms in a compound or ion. So as I just shown you, H2O. Similarly, Na2O, that is sodium oxide. So sodium, we know relative atomic mass of sodium is 23, and because two atoms are there, so 23 times 2 plus oxygen's relative atomic mass is 16, and together it is 62. Now if we want to take it into molar mass, we need to put gram into this. That's only the difference between relative and molar mass. So relative atomic mass of sodium is 23, relative atomic mass of oxygen is 16, molar mass of similarly H2SO4 if you want to calculate, that means how? The same way, 2 hydrogen, that is 2, sulfur 32, oxygen 16 times 4, and together you can add them and then put gram. So as soon as you put gram in with a relative molecular mass, it turns into molar mass. That's only the difference. So until unless you won't put it with gram, it will not be molar mass. So when you want to calculate the molar mass, you need to add up all the relative atomic masses of that chemical species, whether it is a compound or ion. So I hope this makes sense to you. So that's how it is. Otherwise, if you want, I can show you here. So what happens, like for example, say H2O, as I was saying. So hydrogen's relative atomic mass is 1 because it is 2. So 1 times 2, now this bracket, plus oxygen's relative atomic mass is 16. So together that is 18. Now this is relative molecular mass until you put gram. As soon as you put gram, this becomes molar mass. So molar mass of H2O is 18 grams. So that means 1 mole H2O equals to 18 gram. That is the molar mass of H2O. So I hope this makes sense to you. So similarly, we can make or calculate the other molar masses as well. So if you say, if for example, if I say any other compound, say NaOH, sodium hydroxide, how to calculate the molar mass? So sodium is 23 plus oxygen is 16 plus hydrogen is how much? 1. So hydrogen is 1. So how much it is? 23 plus 16 plus 1, and that is how much? Can you calculate? So 17 plus 3, 20, and 20, 40. So this will be 40. As soon as we put gram, it becomes molar mass. So that is how we calculate the molar masses, by using relative atomic mass. Now moving further, as we know, 1 mole equals to gram atomic mass equals to 6.022 into 10 to the power 23 atoms. 1 mole oxygen atoms is equal to gram atomic mass of oxygen is equal to 16 gram is equal to 6.022 into 10 to the power 23 atoms. So this is a correlation. 1 mole atom means gram atomic mass equals to Avogadro constant atoms. If we take it in terms of molecules, then instead of gram atomic mass, it turned to be gram molecular mass. Here you need to take care. If we are talking about atoms, then gram atomic mass. If we are talking about molecules, then it will be gram molecular mass. So for example, like if we say 1 mole oxygen molecules, so that means gram molecular mass of oxygen we need to take. And oxygen is 16 because oxygen molecule O2. So 16 times 2 is 32. And that will be equal to 1 mole molecules of oxygen, and that will be equal to 6.022 into 10 to the power 23 oxygen molecules. So that is, if you want, I can show you here as well. So we say 1 mole hydrogen molecule, suppose 1 mole hydrogen molecule. So we say equals to how many hydrogen molecules? 6.022 into 10 to the power 23. And now we know hydrogen means relative atomic mass is 1. So what will be the mass? 1 times 2. So it will be 2 and gram. So 1 mole hydrogen molecule will be 2 gram. And how many molecules will be there? So that many molecules will be there in this. So you can correlate it with other molecules as well. Similarly, 1 mole ions, if we talk about 1 mole ions, so how we can relate it in terms of gram atomic mass or gram molecular mass. So here we can't use those two terms here because ions are there, so that means we need to use formula unit mass instead. So formula unit mass, and it will again be equal to the same Avogadro number of constant like values. Or so 1 mole ion is equal to 6.022 into 10 to the power 23 ions, and that means 1 mole, suppose sulfate ions we talk, so that means we need to take formula unit mass of sulfate ion. So sulfur is 32, oxygen is 16 times 4, and that will be together 96. So how it is? 32 plus 16 times 4. So it is together, it is 64. 64 plus 32. So how much? It will be 96. 96 gram. So formula unit mass of sulfate ion will be 96 gram. And how many sulfate ions? The same number will be the sulfate ions. So I hope that you understand it and you can make a correlation with. Now moving further, the definitions. So the mass number A, which is denoted by A, is the sum of protons and neutrons. I understand that you know this. The mass number, which is nucleon number as well, that is represented by symbol A and is the sum of protons and neutrons in the nucleus of that atom. So for example, carbon, it is 12. The atomic number, that means is a proton number, and Z is the way how we represent it. So the proton number or atomic number is represented by Z of an element is the number of protons in the nucleus of atom, and in the neutral atom it is always equal to the number of electrons. So for example, like carbon, so carbon atomic number is 6, that means it has 6 proton, and also because it is, if it is neutral, that means it has 6 electrons as well. The relative atomic mass is the mass of one atom of an element compared to a scale in which one atom of carbon 12 has a mass of 12. The relative molecular mass is the ratio of the mass of one molecule of a substance to the mass of one atom of carbon 12. So we compare only with carbon 12 isotope. It is calculated by adding the relative atomic masses of all the atoms of the all element in the molecule. That is how we calculate it. So relative molecular mass or relative formula mass for those compounds that do not exist as a molecule like ions is calculated by adding together the relative atomic masses of the elements in the molecular formula or relative formula or ionic formula. So like that we calculate it. Moving further, the empirical formula. So this is like simplest way how we can represent a molecule. So chemical formula with simplest ratio of atoms of a compound. Molecular formula means the exact number. So chemical formula with definite number of atoms of a compound. So for example, like benzene is there. So benzene is the molecular formula. Benzene has the molecular formula of C6H6. So if we simplify it, so we take this 6 common, so we can write it as CH. So CH is the simplest ratio of atoms of C6H6. So that means CH is the empirical formula of benzene, whose molecular formula is C6H6. So we can say, so CH is the empirical formula and C6H6 is the molecular formula. So that is the difference. And what is the difference? The difference is the 6 which we have taken common. So this is the factor by which empirical formula is different from molecular formula. So that we have taken common. Now if the factor we don't know, then molecular formula mass, if this mass we divide by empirical formula mass, we can get the factor this. So if suppose in the question or directly it is given the molecular formula mass is given 78 suppose, and then when this is given the empirical formula mass, we can calculate 12 plus 1 13. So 78 divided by 13 is 6, and that is this number factor. So that is why n is this factor equals to molecular formula mass divided by empirical formula mass, and that is how we get and use it as and when we need to like use in calculations. Determining this empirical formula, how do we do? So we do it in steps. So step number 1, write the chemical symbols along with percentage given. Consider percentage as mass you need to take care of. If something is given like this element is given in this much percentage, this element is given in this much percentage, so you need to consult or consider that as like gram, like mass. Step 2, divide the given mass of each atom or each element by relative atomic mass of that element, not the molecular mass. So for example, if you use oxygen, so it is 16 only, not 32, because normally the students get confused that they sometimes use the molecular mass. So no, it is the relative atomic mass, that means per atom, to get the like moles. So that way you need to use it. So moles equals to mass over molar mass, so you get moles of each element here. Step 3, divide the moles of each element by the smallest moles obtained in step 2. So this step is very crucial. Step 3, divide the moles of each element, like which you have written based on the like division or the atoms present in the or element present in that compound. Now step 4, use the obtained value as a number of atoms per element in empirical formula. So that's we use it like to calculate. Note, if you did not get the whole number values, this is very, very important. So if you don't get the whole number values, do not simply round off the values, but multiply by suitable integers to make the value whole number. Example, if you get 2.5, do not round off to 3 like simply we do in mathematics. We don't do this here because atoms cannot be in fraction and we cannot like make them whole. So they should be the complete, like it should be whole number directly. So if we don't get it, we don't round off them. So we multiply by suitable integers to make the whole number. So for example, this one problem I already solved it here. So for example, a compound has 44.09% of iron and rest chlorine. Determine its empirical formula. So how do we do that? So if the molar mass of the compound is given, that is 127 gram per mole, determines its molecular formula. That's here we will need n, that factor. Okay, but the compound has 44.09% iron and rest chlorine. It means there are two atoms present in this, or two elements present. One is iron and another chlorine. So as I told you, percentage should be considered as gram. So iron is given 44.09 gram and rest chlorine. So percent means out of 100. So out of 100, how much chlorine? So 100 minus the mass of iron, and that's we get 55.91 gram chlorine. And step 2, we divide it by relative atomic mass or molar mass. So iron relative atomic mass is 56, whereas chlorine relative atomic mass is 35.5. And then the division we get here 0.79 and 1.57. Now if you compare these two numbers, which one is the small number? 0.79. So we divide both of them by the smallest number. So 0.79 divided by 0.79 and 1.57 divided by 0.79, we get 2 here, here 1. That means we get 1 atom of iron and 2 atoms of chlorine. That means the empirical formula is FeCl2. So now to find out molecular formula, we use that formula. Molecular formula equals to n times empirical formula, where n is equal to 1. N is equal to 1. Hence empirical formula is equal to molecular formula. Okay, why I am saying n is equal to 1? Because the molecular formula mass is 127. Molecular formula mass is already given 127 gram per mole. Okay, and empirical formula mass, because empirical formula we have already taken FeCl2, so Fe is 56 plus Cl2, so 35.5 times 2, so it will be 71. So if you add them together, it will be similar to the upper value, that is 127. So that means molecular formula mass divided by empirical formula mass will be n, and that n will be 1 here in this case. So I hope that this makes sense to you. isn't it? So that's we are ending this subtopic. I hope you understand. You can like pause, or you can revisit this like this video.